Number 9, it says, given f of x equals this quadratic and g of x equals this linear function, find the addition, subtraction, multiplication, and division, and then determine the domain. Alright, so first off, let's talk about domain. This is a quadratic, so the domain is all real numbers. This is a linear function, so the domain is all real numbers. When we add the two functions, f plus g, that's just going to be 3x squared plus 28x plus 49 plus x plus 7. So final answer is 3x squared plus 29x plus 56. F minus g is going to be 3x squared plus 28x plus 49 minus the quantity x plus 7. So the difference is you got to make sure you distribute your negative right there. So 3x squared, 28x minus x is going to be 27x, and then 49 minus 7 would be plus 42. As far as domain goes, when you add two, it's just becoming another polynomial, another quadratic, so the domain is still all real numbers, and same thing goes here. As far as the next one goes, f times g, we've got to distribute 3x squared plus 28x plus 49 times x plus 7, and that is going to be, let's go over here, some of the space, 3x cubed, and then plus 21x squared, plus 28x squared, and then 28 times 7 would be 140 plus 56, 196, 196x, and then 49, and then I think I'll just start doing some things, and the calculator's up to save some time. 343. So that is 3x cubed plus 49x squared plus 245x plus 343. And when you multiply quadratic times a linear, you get a cubic, which is still a domain of all real numbers. So the most interesting piece is when you do the division. So when you divide f by g, 3x squared plus 28x plus 49 divided by x plus 7. That's actually not the most simple this expression can get, and you need to always think to check it. You've got a quadratic divided by a linear. You might be able to factor that. Personally, I don't feel like factoring that right now. Finding the factors of 3 times 49, that add up to 28. So I'm just going to do synthetic division to see if it works. So I'm going to see if negative 7 is a root of 3x squared plus 28x plus 49. And then you drop the 3. That's negative 21, that's 7, and that's negative 49. Which means not only is x plus 7 a root, but, that is what it's saying. X plus 7 is a root, and the other factor is 3x plus 7. So this is the same thing as saying x plus 7 times 3x plus 7 over x plus 7, which means it simplifies down to the expression 3x plus 7. Okay. The only thing is you also got to talk about domain. So domain would be all real numbers except whatever makes the denominator 0. Even though it's gone, the original expression had it, so x cannot equal negative 7. So what they have is negative infinity to negative 7, and then negative 7 to infinity. They do use the union symbol in between them. As long as you could match it to that, that would be fine. Okay. Number 10. Solve the following radical. So radical equations, you do need to be careful to check for extraneous solutions, because what happens is, in general, when you talk about square root, when you work the problem, you're dealing with this, and you're trying to find when it equals this linear, right? So that would be one time. But when you manipulate it, what happens is you end up dealing with this as well, because when you square things, it automatically imagines that it has both of them, and so you find an extra answer, and so you need to make sure that you get rid of that extra answer. So on here, if we square both, not to say that you couldn't have two answers, because you definitely could. If you had a square root like that, and then it was just like, when does it intersect? You could intersect twice and put one here. But a lot of times it's an extraneous solution. So we square both sides and we get 32 minus 4x equals x squared. I'm going to get everything on the same side, and I'm going to keep the quadratic positive. So I'm going to subtract, or I'm going to add the 4x over and subtract the 32. I want to find the factors of negative 32 that add up to 4, and that is a positive 8 and a negative 4. I'm still trying to solve for when it equals 0. So my answers are potentially negative 8 and 4. But I got to plug them back in. So if I plug in negative 8, then I get the square root of 32 minus 4 times negative 8 equals a negative 8. And here's the thing. A square root will never equal a negative number. So we're good. This ends up being the square root of 64, and the square root of 64 is not negative 8, it's positive 8. So 8 is out, negative 8 is out. And then as far as 4 goes, you got the square root of 32 minus 4 times 4, which is 16, equals 4. And that is true. The square root of 16 is 4. So the only answer is 4. On B, again, we need to, the square root is isolated, which is good. If it wasn't isolated, we would need to move everything over until you just had the square root on this side, and then we'll square both sides. So we're left with x plus 14 equals, and we're going to expand this out. So x minus 6 times x minus 6 is x squared minus 12x plus 36. So that means x squared minus 13x, and then we're going to subtract the 14 over, which gives me 22. Yeah. So the factors of 22 that add up to negative 13 are negative 11 and negative 2, which means my answers are potentially 11 and 2. So if I plug in 11, I get the square root of 11 plus 14 equals 11 minus 6. 25, the square root of 25 is 5. That is good. But this one, it says 2 plus 14. The square root of that equals 2 minus 6. Well, that's a negative, and a square root will never equal a negative number. So the only answer is 11. On absolute value equations, you got to remember that when you're solving an absolute value equation, you're solving for when, especially if the absolute value equals a number, when the absolute value equals a number. So you got to remember that there's two answers when you do this, as long as the number that we're talking about is there. So if I had an absolute value like this, and then I said, when does it equal that number? It never does. Okay, so you got to be aware that you could end up with false solutions. Or, well, not false solutions, but you can find things that aren't there just by thinking, oh, I know the process, and not thinking about what you're doing. So the absolute value of 2x minus 3 would equal 11. If 2x minus 3, the interior, equaled 11. Or if this whole thing right here equaled negative 11. The absolute value of negative 11 will also equal 11. So we can set 2x minus 3 equal to negative 11 as well, and we solve for our two answers that way. So we're going to add the 3, and then solve when we get 7. We're going to add the 3 again, only this time it's going to be negative 8. And so my two answers are 7 and negative 4. Okay. For part B, we've got an absolute value. First, you have to get the absolute value alone, so we're going to subtract the 8 over. But when we do that, we get absolute value of x plus 1 equals negative 1. And the fact of the matter is that an absolute value function will never equal a negative number. So that's no solution. You can also think of it like this. If I took an absolute value function and I go to the left 1 and up 8, and then I ask you to tell me when it equals this line, it never will when it equals 7. So, no solution. Solving a system. Okay. So we've got elimination, we've got graphing, we've got substitution. I'm going to do elimination first, and then I'm going to show substitution, just in case you'd like as well. Okay, so the easiest thing, it looks like, to eliminate is the y's, because I've got a -2 here and a positive 1 here. So if I were to just multiply the bottom equation by 2, then I would have 3x minus 2y equals -5. And then I would have 8x plus 2y equals 16. So we add those two equations, and we get 11x equals 11. So divide by 11, and I get x equals 1. And if x equals 1, then I just go back and plug it into either one of these equations and solve for y. So I'm going to go ahead and plug it back in here. 4 times 1 plus y equals 8, which means y equals 4. So the answer is the coordinate point 1, 4. That's elimination. Another way to do it would be substitution. Substitution, you want to solve for a variable and substitute into others. Here, it looks like y is really easy to solve for, so I'm going to say y equals 8 minus 4y. And then what I do, 4x. So I get y by itself. I get that expression, and then I plug that into the first equation for y. So 3x minus 2 times 8 minus 4x equals -5. So I've got 3x minus 16 plus 8x equals -5. I get 11x, and then I add 16 over, and I get 11 again. And I get x equals 1. And then I do the same thing. If x equals 1, then right here, I've got y equals 8 minus 4 times 1, which is 4. All right. Now, I could have also worked this by multiplying this by -4 and this by +3, because then I would have a -12 and a +12, but it's just easier when you have the ones that lend itself to it. B. So I'm looking at this, and it looks like, I mean, these are opposite signs, 2 and 3, but I would have to multiply this by 3 and this by 2, whereas this one, if I just multiply the bottom equation by -5, then I'll have, I can do elimination pretty quickly. So I've got 5x plus 2y equals 0, and then I've got -5x plus 15y equals 0. So add them, and I get 17y equals 0. Divide by 17, and I get y equals 0. And so if y equals 0, then I plug that back into either equation. I'll go ahead and plug it into the first. 5x plus 2 times 0 equals 0, which means 5x equals 0, x equals 0. This is a weird answer. I doubt they would give you an answer like this or a problem like this, but, I mean, whatever. If I were to solve for y on each of these, I would get y equals -5/2 x and y equals 1/3 x. They both have a y-intercept of 0, so it makes sense that they go through the origin. They both go through the origin at 0, 0, so that's their point of intersection. Because the idea of solving a system is finding where they equal each other, their point of intersection, which is why graphing is also an option. Okay. On C, I've got a negative and a positive, so I could multiply the top equation by 5 and the bottom equation by 3. But I've got 4 and 2, and all I got to do is multiply this by -2, and then I can simplify. So I've got 4x plus 3y equals 15. I'm going to distribute that. I've got -4x, let's see, that is plus 10y, and that is -2. So I get 13y equals 13, so y equals 1. And if y equals 1, then I'm going to say 4x plus 3 times 1 is 3 equals 15. Subtract the 3, and I get 12 divided by 4, and I get 30. And so the answer is the coordinate point 31. Okay. On number 2. A company that manufactures running shoes has a fixed cost of $300,000. Additionally, it costs $30,000 to produce each pair of shoes. They are sold at $80 per pair. Write a cost function of x, a cost function C of producing x pairs of running shoes. So x represents the number of pairs of running shoes. So per pair of running shoes, we have a fixed cost of $300,000 plus $30 per pair of shoes. So that's why it's $30 times x, because anytime you get the per or each pair, then you multiply. Okay? Revenue is how much money you're bringing in, and we're bringing in $80 a pair of shoes, so that's 80x. Now, some of you are confused. You're like, why wouldn't I be subtracting these? And that's because that would be the profit function. So revenue is just what you're bringing in. Cost is what you're spending. Profit would be revenue minus cost, and hopefully that would stay positive. The break-even point is when you're making the same amount that you're spending. So that would be when the two equal each other. When 300,000 plus 30x equals 80x. So we're going to subtract 30, and we get 300,000 equals 50x. Divide by 50, and you get x equals 6,000. That means 6,000 pairs of shoes. Now, they did actually, the answer has 6,000 and then comma 480,000. So you have to understand that, like, if this is my x, then what is my y? The y is the cost and the revenue. So if I plug in 6,000, I get how much revenue, how much money we're bringing in, which should be the same amount as how much we're spending, and that amount is 480,000. So I'm going to write down 6,000 pairs of shoes, and that's when cost and revenue both equal $480,000. It is going to be multiple choice though, so if you have an answer and like you find 6,000, then just like, you know, match it to the best answer. Okay. A 6,000 seat theater has tickets for sale at $27 and $40. How many tickets should be sold at each price for sellout performance to generate a total revenue of $198,400? Use a system of equations to determine the number of tickets sold. So this is a total number. It's a total amount of money brought in. This is a total number. It's a total number of seats. So we have two different things going on. We have seats sold for $27, and then we have seats sold for $40. So what I know is that this X and Y represent the number of seats or tickets, whatever, tickets, I guess. I guess it's the same thing. We're talking about sellout performance. And two things I know. I know that there are 6,000 seats, so that means the number of tickets at $27 plus the number of tickets at $40 has to add up to 6,000. I also know that $27 times the number of X tickets plus $40 times the number of Y tickets has to add up to the total amount, $198,400. And so I've got a system, and I can solve using elimination or substitution, whichever one you prefer. I'm going to go ahead and do elimination just to make it easier on myself. I'm going to multiply the top equation by negative 27, because why not? So negative 27x and then minus 27y equals 27 times, negative 27. Negative 27 times 6,000. And that is negative 162,000. So this is a reminder, I just multiplied the top equation by everything by negative 27 so that the x's would simplify out. Those are gone. I'm left with 13y equals, and that would be 400 and, I don't know, yeah, 36,400, and then 8,400. Okay. And then I divide by that, by 13. And I get that there are 2,800 seats sold at $40. And then I know that the number of seats has added to 6,000. So if Y is 2,800, then this is 3,200. So there are tickets at $40 and 3,200 tickets at $27. Give the augmented matrix that represents the following system. So an augmented matrix is really just a matrix that represents, you plug in the variables, and so we've got 1, 3, negative 2, and then you put the bar or the equal sign, and then 1. Okay, so this is x and y and z and then the constant. So x is 4, and keep that in mind in case things are out of order. Y is 1, z is 7, and then the constant is -3. X is 5, there is no y, so we put a 0, 2, and then -4. And that's page 2.